Here we have problem number 21. 1700 Newton irregular beam is hanging horizontally by its end from the ceiling by two vertical wires. So we have wire A and B. Each length is 1.25 meter long. The weight is given of the wires, which is 1.5 Newton. The center of gravity of this beam is 1/3 of the way along the beam from the end where Y is. If you pluck both string at the same time, at the beam, what is the time delay between arrival of two pulses at the ceiling? Okay, so basically we have two wires, okay? The wire A, say, and wire B. They have same length. The weight that is on the center of mass of this thing is 1700 Newton, okay? Then the weight of this wire is very small, okay, comparatively to this weight. So it is equal to the weight of the string is 1.7 newtons. Okay, now the first of all, so in the question was asking, since the weight on here located here, center of mass, if it was on the center and if our wires are the same length, same mass, same material, then pulses will reach at the same time to the ceiling. But however, the weight of the center of mass is here, so therefore the pulse that is traveling here and that is traveling here will be different. So we have to calculate that difference in the timing. So that will be delta T, TA minus TB, okay? We have to find what is the TA and what is the TB. So TA will be length, so we have same length, divided by the VA. So VA will be basically VA that is traveling up, and then we have VB that is traveling in the YB, okay? If that's the case, then we have to divide L divided VA, L divided by VB, and you have to subtract them. Now, if we know the L is given, then we don't know what is the VA and VB, okay? That one we have to calculate it. If you cut from here, then you know that this weight will be equal to the TA and this weight will be equal to the TB. Or we can say that TA plus TB will be equal to the weight, which is 1700 Newton. Now, you can also calculate that TB is equal, mathematically, that 2/3 multiplied to the weight, and then you can calculate what is the tension on the TB. So after calculating, it will be 1133 newtons. And then for the TA, which is this one, will be 1/3 multiplied to the weight. So if you do calculate it, you will get for the also tension for the TA. So you have tension for the TB and TA. Now we have to calculate the speed. The speed is defined on the speed on the string or in the rope defined by the tension over mu. Okay, so the VA will be tension A divided by the mu. So mu is equal M over L, so L goes up. So TAL divided by M. So you plot the numbers and you get speed for the VA, and you can calculate also speed for the VB. Then after that, you just plug it all things here, and then you can calculate change in time, that pulse A or pulse B that reaching to the ceiling.